Dubara, Bismillah Rahman Rahim. My name is Zahid and these are my group members, Mujtaba, Zain, and Arslan. And our topic is remote laboratory cloud computing. Next slide, please. Our agendas are introduction, cloud-based system architecture using tutorials, conclusion, and future work. Next slide. Before we get into the beginning of VR lab, let me explain the abstract of the research paper. So in this research paper, it is explained that experience is the most important factor that makes an engineer, and it is achieved through practical work with the help of laboratory equipments. In the case of long distance education, there is no communication between teachers and students, so they introduce VR lab. So now the beginning of VR lab, that how they started. UNED, National University for Distance Education, it is a Spain university which created a program to build and manage remote laboratories aimed at improving student physical activity. VR lab are visible and remote laboratories. VR labs actually do not have access to real physical devices but are not based on simulation. They are introduced, they also introduce the system evaluation aimed at assessing the quality of the system in terms of three different concepts, which are practical use, easy to use interface, just like your GUI Windows 10 that you are using, and the virtual communication. We can take Zoom meeting as an example. Next slide, please. So the introduction, the Spain National University of Distance Education, UNED, is the largest university in Spain with more than 200,000 students nationwide. They develop the virtual remote laboratories management system called Tutores. And the system and the program is based on the principle of cloud computing and virtualization are main 2 points. To powerfully, continuously provide students with the necessary hardware and software resources so that they can acquire practical skills in any subject they are interested in. Teachers use the program to create virtual remote laboratories via labs based on templates, and each laboratory can be made with one or more virtual machines depending upon the actual capability used for the acquisition of this laboratory. The purpose of the laboratory, that why we are using the laboratory for today's lecture. Next slide, please. Continuous. The term remote means that the actual devices have been accessed remotely. In this paper, they propose a new concept called virtual remote laboratories. VR labs share features from virtual and remote laboratories, but with a clear difference above them. Proposal calls it visible because it does not reach actual devices, it reaches the visible devices. The example that we can take is when you do switching and routing by uh, the end of the server, you assess it with your PC. This is the example. This is the difference from traditional laboratories because this consists of simulation, but what we use is not simulation. We assess virtual machines that we use real operation systems and provide real-time network services with the help of that. Benefits. Cloud computing virtualizations allows for powerful dynamic work environments across a variety of research and industries. Amongst the benefits they provide are flexibility, diversity, efficient and effective use of technical staff, improved error correction, efficient use of computer equipments and reduce power consumptions like they will save their electricity. the ability to add, remove capacity on demand, or system availability in hands app, just like your uh, UMT portal, online UMT portal. Student will gain the technical knowledge that will become their most valuable asset when they begin their professional career. Next slide. Cloud-based system architecture, and this will be presented by Mujtaba. Please, Mujtaba, carry on from this one.
Assalamu alaikum. Bismillahirrahmanirrahim. Uh, my name is Mohammad Mujtaba Naeem and I will present the topic cloud-based system architecture. We have main categories of cloud technologies like IaaS, PaaS, and SaaS. What are these? By the way, these terms are IaaS stands for infrastructure as a service, and it is form of cloud computing that gives virtualized computing assets across the web. IaaS is one of the classifications of cloud computing administrations. Now we have PaaS. What is PaaS? PaaS stands for Platform as a Service, and it gives cloud segments specific programming that are being utilized for applications. SaaS, we have SaaS. It stands for Software as a Service. It conveys applications over the internet. Furthermore, clouds can be defined as private, public, or hybrid, depending on who owns the infrastructure where the system is running, whether it is the firm or a cloud service provider. Tutor's system has a layered architecture like I will describe you in next slide. So basically, this is the diagram of Tutor's system. We have management plane, cloud plane, platform control plane, data center plane. We are seeing dashed lines, dashed arrow lines. What are those? Dashed lines represent relationship between components. What are those components? For example, the web services in the management plane uses all the databases to store the layouts shown in the cloud plane. Then for the platform control plane, each of these is utilized to generate the VMs and system that comprise VR labs. Virtual labs in turn are hosted in their local servers or by cloud service provider. Next slide. Now we have layers and its implementation in Tutor system. What are those layers? Topmost layer is lab management or management plane. Both are the names, which is the construction, deletion, and modification of laboratories, as well as the creation, deletion, and modification of the templates. Then we have second layer. What is second layer? Second layer is cloud plane. Cloud plane which provides the templates that may be used to create laboratories, and then templates may be reused at any time. Now the third layer is platform control plane, which provides platform level services that offers the running environment for laboratories, cloud computing, and networking services. These are included in platform control plane. Now we have the last layer. What is this last layer? It is the bottom layer, which is data center plane. It contains the physical resources where laboratories are placed. Now we have the implementation of these layers. The system implementation is based on only two technologies, a hypervisor and a virtual infrastructure manager. We will discuss hypervisor and virtual infrastructure manager in a short while. What is this hypervisor? This hypervisor is a piece of software that runs on a system and creates an environment in which virtual machines may be hosted. The physical system on which the hypervisor is running is referred to as the host, and the virtual machines that operate on the hypervisor are referred to as guests. We have an example of hypervisor, which is we have VMware ESX hypervisor that offer the working atmosphere for the laboratories located in most of the university premises. Now we have the second implementation role. We have OpenNebula, which is Virtual Infrastructure Manager, which is the second technology of system implementation. What is this? This is another cloud technology on which their advances rely. It manages laboratories, registration, monitoring, and deployment, as well as the VM of network templates from which laboratories may be built, thereby covering the cloud plane of the architecture. Now we have finally the management plane. What is this? It is provided via the web application that interfaces with OpenNebula and numerous databases, where database user refers to student and DB practices refer to the practical task. Now tutor system which Zain will be share you. Thank you.
Assalamu alaikum. My name is Zain and I will be discussing the steps which will be required in using tutors. And there are following six steps which will be required in condition to use tutors. And they have a web application which will assist the user by providing a graphic user interface which is more efficient and convenient way to do the task. The first slide in the using tutors is a creation of virtual switches. They are using application programming interface which is in abbreviation of API for the connectivity of VR labs, and they are using API to create virtual switches by input parameter according to the requirement. And after these steps, ESXi server will be ready to host the VR labs. And most importantly, this is a necessary step if our requirement is to define a specific network configuration, but it is not compulsory since VR labs can be connected to an existing virtual switch at ESXi server. And the second step is the creation of network and users. This step may not be necessary if network and user have already been created. For this step, web application takes CSV files which are used by a script to create network and user. And I will now be discussing about the structures of CSV files for network and users separately. The CSV file structure for network is bridge, network, and DNS. And as well as the structure of a CSV file of for user is username, password, group, and network. After this, these files will be used by a script to create users and networks. And after creating the users, in the user section, it creates the user both in Linux and OpenNebula as well. The next slide is session. And the third step is the registration of virtual machines in OpenNebula. Registration step is also very important in step in order to use virtual machine in our application. A virtual machine must be created at ESXi server and transferred to OpenNebula node. After this, a script registers the virtual machine in OpenNebula. In this way, the registration of virtual machine in OpenNebula is carried out. And next step, next slide. And the fourth step is the deployment of VR labs. This this is this can be called a final step in building VR labs. This is carried out through a second script which runs for each virtual machine required for VR lab. For example, Jane Doe and Jane Doe. These two are both different names. Students may belong to group 1, whose practical exercises 3 requires VR labs with 2 virtual machines. In this case, the script will be executed 4 times since 4 virtual machines are required. Next slide. The fifth step is the use of virtual remote labs. Once the virtual remote labs have been created and configured by the lecturers using tutors, student can begin using them. How students connect to the VR labs may depend on the specific topic for which they are being used. And the final step uh, in this procedure is shutting down the virtual machines and removing the VR labs. When the faculty decides that VR labs are no longer needed, they can shut down the virtual machines and remove VR labs. Once they shut down, all the components will be removed, leaving the system completely empty for the next use. Now I will invite Arslan for the further presentation. Thank you.
Assalamualaikum. Uh, okay. Now I will here to conclude our today's topic and also discuss some future work of remote laboratories. First of all, I want to tell you what is remote laboratory. Uh, it is also known as online laboratory and remote workbench, which is used to telecommunication remotely conduct real experiment at the physical location of the operating technology, which means that we can do remotely work from one location to another. Okay? For example, if we had a server in Lahore and we want to do some heavy experiment on some acids and other things, and we want to do in remote areas for our security purpose. So so that at their remote laboratories will help us a lot. This is the reason. That's why we are using this so much in our future work and also in current situation also. So I will tell you some advantages for this. First advantage is relaxed time constraint. Adopting a place of each student if it was sufficient time life in time in lab. For example, in study in educational institutes, we have few labs for practical for taking practical of different students. So in remote laboratories, each student can participate at the same time. For example, if we have 30 students, then we just have to sign in different from our PC. They will do their work remotely, and which will give you a better experiment exercise. Relax geographic constraints. As I discussed earlier, discarding the physical location of student. For example, if in this corona pandemic, we are not ready to go to different labs and perform them, but by using remote laboratories, we can perform that experiment from here to anywhere in the world. And economics of scale, as sharing lab allows sharing of large fixed cost of trading buildings and also improve quality of experiment. It can be repeated to clarify depth measurement in labs. Yeah. Improve efficiency as students may improve efficiency of the time spent at lab by repeating it again and again. Improve security and safety. Because we are doing this from remote areas, it is safe for us to experiment on harmful objects. Now, I will share some disadvantages. The disadvantages differ depending on the type of remote laboratories and topic area. The general disadvantages compared as proximal hands-on laboratories are risks of hands-on troubleshooting and debugging experience, lack of equipments and setup experience. Of course, this is some new product and some new experiment, so maybe we cannot set up this easily because it's required more resources. Just like a heavy server and strong data connection, just like 5G, and some reports that can move from taking by taking instruction from internet. And I would just want to share our current system capabilities. Online session booking utilize database and online interface. Currently, we have an online interface to remote that labs and also authentication to satisfy security requirements. Just like we have to log in before we use our remotely lab. And also we have some desktop applications and time limit, bandwidth limit, and also we can use this from live camera allow which allow our better experience, and can also we can also refresh at any what is our future work? So, as I discussed earlier, our current capabilities. So, our future work can be just guess if we are using this from server side, like we are not using from a personal computer which we use daily in our daily life. So, we have to develop a special application for that server because a server can control multiple threads at the same time, and we have to develop some different application which can support multiple displays and also can do multiple threads at the same time, which means we can do multiple tasks and can perform same tasks at different categories in different categories at the same time. So by providing a better dashboard we can improve this, and also giving them updates regularly. That update also improve our software and also add different hardware capabilities. For example, firstly, we use that just for our test tubes, but now we want to add some different categories hardware which can help us by updates. And we also set limits on different hardware resources and also on software resources by hiding, zooming, and showing some information deeply. So this is our today's topic. Allah Hafiz and goodbye.